Greetings. Let's talk about initial value problems. These are problems that look like this. They may be phrased a little bit differently, of course, but it's going to be basically find a function y so that when I differentiate it, I get some known function f, and that I have some particular, that the function y at time 0 is equal to some particular value y0. Problems like this are actually integration problems. So integrals weren't specified at all in the formulation of the problem that I said right here. What we're actually doing is we're going to solve y equals the integral of f of x dx, where y of 0 is equal to some given value y0. I also believe that if I have some value other than 0 here, it's still an initial value problem, because I don't think that time or space have to start at 0, but oftentimes it's 0 right here. If it's not 0, then it's some other value, and the process is exactly the same. And I think that it's important that we generalize that right here. Let's practice one of these. Okay, so this is the generic form of it. So now let's get specific. Let's solve the integral of let's see here, the integral of 10x to the 7 dx y equals where y of, let's say, 0 is equal to 13. I'm going to erase my little bits of equal signs there. Fine. Boop. Another way of saying this would be solve dy dx is equal to 10x to the 7 with y of 0 equals 13. So these two phrasings are equivalent to each other. This one's in terms of a differential equation, because I have differentials here and I have an equation. We're not going to get into the world of differential equations too heavy in this class. So I think that's as far as I really want to go. Okay. So essentially what we need to do are a couple of steps. The first thing we need to do is integrate to find the general solution. And when I say the general solution, I mean the one that has plus c in it. So we're going to integrate y equals the integral of 10x to the 7 dx is equal to 10x to the 8 over 8 plus c. Here's that plus c. And then I'm going to simplify this. That's equal to 5/4 x to the 8 plus c. Okay. So I found my general solution that has my plus c in it. And now we're going to find step 2, find the particular solution. That is to say, the value of c. And this is where we're going to use our initial condition to specify the value of c, because I happen to know that y of x is equal to 5/4 x to the 8 plus c. Well, that means that y of 0 is equal to 5/4 of x to the 8, which is 0, when x is 0, plus c. But I also know that that has to be equal to 13, which implies that c equals 13. So we found the particular value of c. This was the general one. Here we have the particular. So that means that y is equal to 5/4 x to the 8 plus 13. And this is my final answer. It has no plus c in it. The additive constant has a concrete value in it. So what would be different if I wasn't given y at 0 equals 13, but some other value? Well, let's try it and see how the problem would be different. So let's replace 0 with a 1, because 1 is also convenient. It could be any value whatsoever. 1 is not special. We're still going to integrate to find the general solution. The general solution is still this. We still have plus c. The only part that's affected by this value here is when we find the particular value of the solution. So I need to go back and edit this now. So I don't have y at 0 equals 13. I have y at 1 equals 13. So I need to put in y at 1. Okay, so y at 1 is equal to 5/4 of 1 to the 8 plus c. 1 to the 8 is just 1, and that's equal to 13. So I have 5/4 plus c equals 13, which means that c is equal to 13 minus 5/4. And let's see here, 13 is equal to 26 over 2, which is 52 over 4. And 52 minus 5 is 47 over 4. Yep. So that's my value for c, but I'm not quite done. We'll have solved it once I've written down the actual thing for y. Y equals 5/4 x to the 8 plus 47/4. And there I'm done. Again, I have a concrete value for my c, and then the general function for the antiderivative. Okay. So these initial value problems are pretty straightforward. It's basically integrate, and then plug in a value, set it equal to, and solve for c, which is generally going to be pretty easy. So thank you so much for your attention today, and I will look forward to seeing you for our next video together. Bye.